Hello students, good morning all. So hope your preparations are going well. So today we are discussing about the new topic from redox reactions. Okay, so hope you might have seen the thumbnail. If I am audible or visible, please let me know, students. Okay, in your comment box you can comment, right? So let's get started. So redox reaction is a small chapter, and we have already discussed in the previous class about the oxidation numbers, reduction, oxidation reaction and reduction reaction, and also we have done certain problems to how to calculate the oxidation numbers of the elements present in a compound. Okay, so there we have discussed in detail about all the rules which you have to follow while finding out the oxidation number of a particular element. So in that itself we have discussed in detail how to assign numbers for different elements. Okay, so all the rules have been discussed there. So today we are going a bit forward, that we are going to discuss about the titrations, that means the reactions or how to balance the redox reactions. That's what we are focusing on today. So there are basically two methods on how to balance the redox reactions. So I'll teach you both the methods, and also you have to be aware that the redox reactions can take place in acidic medium as well as in basic medium. So in acidic medium you have to balance in a particular way, and in basic medium you have to balance in another way. Okay, so both the ways I'll make it simple and teach you how to solve that, and also we will be doing some problems regarding the redox reaction, balancing the redox reactions. Okay, so now let's get started, and I welcome you all to APJ Academy. Now okay, wait a minute. Yeah, so dear students, this is all about our full year course, and you can see that what all we provide. And as you all know, I have been telling you for the past 2 months, right? And you can see that the PDF materials, what we provide all the complete modules of each chapter in detail, which concepts you have to study, what you have to do, and also there is a bank of questions where you have to solve. You know that for preparing the competitive exam, the solving question bank is prerogative. Okay, it's most important part of your preparation. And we also provide 25 major test series where you can practice it. And it's another important feature is that we always have a query solving, and you do not worry about any doubts. You can directly ask your mentor, and you can get your query solved immediately. And also we provide lessons, and we provide freely we provide YouTube lessons, and apart from that other lessons also will be provided for you. And there are assignments after each session. Will be providing you assignments, which is very important in order to check whether you have understood the concepts thoroughly and properly. Okay, and all these we are providing just for rupees 490 per month. That's the most important or the most exciting about our platform. So you can crack JEE or NEET with this enormous discount, and only 490 rupees per month what you have to pay for all this. Okay, so students, if you know others who are who wanted to crack JEE or NEET, you can refer them to this platform. Okay, now if you are watching the channel for the first time, please subscribe to the channel, because I'm sure and I guarantee you that this channel will surely add value to your preparation, and it's completely free. We are providing regular classes, and that is for free, and so that you can subscribe to our channel. So it will surely add value to your preparation, and in this channel will help you in cracking your NEET exam. Okay, so this is about me, students. My name is Roshan, and I'm MTech postgraduate, was a National Olympiad winner with 6+ years of experience in this field, and guided more than lakhs of students. Okay, so now let's get started with the first method of balancing the redox reaction, that is half reaction method. So here students, I have already told, in balancing redox reactions we have two methods. One is half reaction method, or you can also call it as ion electron method, and we also have oxidation half reaction method, and in each method there are two cases. And you can see here that there is a case 1, which means we are doing the redox reaction in acidic medium. So if the reaction is taking place in acidic medium, you have to balance it in a particular way. Okay, similarly if we are taking in the basic medium, you have to balance in another way. So all this we are going to study in detail, right? So you can see that in case 1, that is in acidic medium, what you are going to do. See students, this is the general reaction. That means A giving B, and H plus indicates that this reaction is taking place in acidic medium. Okay, what is the first step you have to do? See, the very first step you have to do is that you have to identify oxidation and reduction half reaction, and you have to separate them. So students, how can you identify oxidation and reduction half reaction? See, where the we have in the last class we have discussed that where the oxidation number is increasing, we say that oxidation takes place. Where the oxidation number is decreasing, we call it as reduction. So based on assigning the oxidation numbers to the elements, you can identify where the oxidation is taking place and where the reduction is taking place. So once you have identified the oxidation reaction and reduction reaction, actually what do you mean by redox reaction? Redox reaction means in a reaction, in a single reaction, oxidation and reduction takes place. So obviously in a redox reaction, one will be oxidized, other will be reduced. So we identify the oxidized compounds and we identify the reduced compounds and we will separate them. Okay, that is the first step we have to do here. Now coming to the second step, dear students, I am just explaining the points now, and after explaining these points we will do certain problems so that all these points will be clear for you once we start doing the problems. Okay, so don't worry about that. First you have to focus here, concentrate here and understand what I am telling. Okay, and the second point, so first point is clear, hope it is clear. You will be given a redox reaction and you will be told to balance it, and they will mention whether it is in acidic medium or basic medium. So what you have to do is that first of all you have to identify the oxidation reaction and reduction reaction by assigning oxidation number to the elements, and after finding out the oxidation reaction and reduction reaction in the particular reaction, you have to separate them into two reactions, that is oxidation half reaction and reduction half reaction. Okay, so after that what you have to do is that second step, balance all the elements. You have to balance all the elements other than hydrogen and oxygen. So before balancing, you have to balance hydrogen and oxygen, but before balancing hydrogen and oxygen, what you have to do is that you have to balance all the elements other than hydrogen and oxygen. Okay, that is the second step. Now coming to the third step, what is the third step? You have to balance oxygen atoms. Now before balancing hydrogen atoms, so we have kept aside oxygen and hydrogen, and we balanced all the other atoms, like carbon will be there, nitrogen will be there, sulfur will be there, and we have balanced other atoms, and we kept aside oxygen and hydrogen. And after balancing all other elements except hydrogen and oxygen, now we have to balance oxygen. Now how to balance oxygen? Oxygen atoms are balanced by the help of water. That means add water where oxygen atoms are less. See, we have LHS and RHS. So in LHS or RHS, where the oxygen atom is less, see, let's say here there are three oxygen atoms, and here there is only 2 oxygen atoms. That means in RHS there is only 2 oxygen atoms. So I have to add 1 oxygen atom in order to balance. So in order to balance them, I have to add 1 molecule water. Hope this is clear. So wherever the oxygen atoms are less, you add the corresponding number of water molecules in order to balance the oxygen atoms. So now we have balanced the oxygen atoms. Now what is the fourth step? Fourth step is now we have to balance the hydrogen atom. That is the last step. So balancing the hydrogen atom, what you have to do, since it is acidic medium, you have to use H plus ions in order to balance the hydrogen atoms. So wherever required, I have to add H plus ions and balance the hydrogen atoms in both the sides. So wherever it is greater, you add the H plus ions on the lower side, balance the LHS and RHS. Okay. Once the balancing of hydrogen atoms is also completed, now what is left? One thing is left, that is the charge on the reaction, the total charge on the reaction. The charges on LHS and charges on RHS is different. Then you have to use electrons to balance that. Now wherever the positive charge is more, you add electrons to that side and decrease the value. Okay, decrease the value and balance the both the side. The charges on both the sides should be equal. So we use electrons in order to balance the charges. Hope that is clear, students. Now the last one. Add both oxidation and reduction half reactions such that electrons are cancelled out. Now that is the last step. The sixth step is, now after doing all the charge separations and charge balancing, hydrogen balancing, oxygen balancing, all the balancing, you can now bring both the reactions together, add them, and you have to confirm that by adding, the electrons have to get cancelled. Okay, by adding both the reactions, the electrons have to get cancelled. Okay, so maybe this point will be a bit confusing for you, but once you start solving the problem, everything will fall in place and you will understand how to solve it. Okay, now here we are going to do 2 problems which will help you understand these balancing concepts. Okay, students, let's take the first example. We are going to discuss about Cr2O7 2 minus plus Fe2 plus giving Cr3 plus Fe3 plus. Okay, and these in acidic medium. Okay, so acidic medium, we are doing the examples of acidic medium. So if you want, you can just give the indication in the question that is in acidic medium. Okay, now what is the first step? First step is to identify the oxidation and reduction reactions. Let's see, here you can see that Fe2 plus have got converted to Fe3 plus. Fe2 plus got converted to Fe3 plus. Yes. Now here let's find out the oxidation. So here Fe2 plus have undergone oxidation. Now let's find out the oxidation number of chromium in this molecule, that is 2x minus 2x plus 2 into 7 into minus 2 equal to, charge on the molecule is minus 2. So 2x minus 14 equal to minus 2. That means 2x is equal to 12, x equal to 6. So the charge on chromium, or the oxidation state on chromium, is plus 6 and it got converted to plus 3. That means it has undergone what? It has undergone reduction. It has undergone reduction. So now from here we got that the oxidation half reaction and reduction half reaction. Let's separate them. Now see here, Cr2O7 2 minus giving Cr3 plus. So from here, what we have to do is that we have to balance. Here you can see, first we have to balance elements other than hydrogen and oxygen. So here in the LHS you can see that there are two chromium atoms, and in RHS only one chromium atom is there. Okay, so I have to multiply 2 here. So now a chromium is balanced. Now next is we have to look for oxygen. Here there are 7 oxygen, so I have to add 7 water. Here there is no oxygen, so I have told you in the next step what we have learned is that you have to balance oxygen. While balancing oxygen, you have to do it with water molecules. So how you have to do it? By adding water molecule on the side where there is least number of oxygen atoms. So here in the RHS there is no oxygen atoms, but in LHS there is 7 oxygen atoms. If 7 oxygen atoms are present, then you have to use 7 water molecules in order to balance it. Now 7 water molecules, I got it here. Okay, now what is next? Next you have to balance hydrogen. Here in the RHS there are 14 hydrogen atoms. In LHS there are no hydrogen atoms. So by using H plus I have to balance hydrogen atoms. So 14 H plus I will be using. Now chromium is balanced, oxygen is balanced, hydrogen is balanced. What is last one? Balancing the charge. Here you can see that here there is 2 minus charge and 14 plus charge. So 14 plus and 2 minus giving 12 plus charge in the LHS. So 12 plus charge is in the LHS, and in the RHS you can see that there is 2 Cr3 plus. That means 1 Cr3 plus is 3 plus and 2 Cr3 plus means 6 plus. So here plus 6 charge, and LHS it is plus 12 charge. So how we are going to balance it? Here you can see that this is the minimum charge, this is the highest charge. So you have to add electrons on the highest charge side in order to balance them. So what I have to do? 12 plus charge should be reduced to 6 plus charge. For that I have to add 6 electron in the LHS. 6 electron in the LHS. Now let me completely write this reduction reaction as Cr2O7 2 minus plus 14H plus 6 electron giving 2 Cr3 plus 7 H2O. Dear students, now our reduction half reaction have been balanced. Now what is next? Now next is oxidation half reaction. Let's take the next page and we will do the calculation there. So we know that in the oxidation half reaction, Fe plus 2 is giving Fe plus 3. So this is so easy that here Fe is already balanced. There is no oxygen, there is no hydrogen. So only charge is present. Okay. So here it is plus 2 charge, here it is plus 3 charge. So I'll add 1 electron over here. So that what happens? This becomes, here it becomes total charge of plus 2, here also plus 2. Now this is balanced. Okay. So now we have to add both the reactions, oxidation reaction as well as reduction reaction. But what is the condition of adding both the reaction? The electrons should cancel each other. So let's check here. Here we have 6 electron on LHS and here we have just 1 electron on RHS. So what I have to do is that I will multiply this equation with 6 so that the electrons on the other reaction and this reaction becomes equal. Okay. Just you have to do one thing is that the number of electrons on both the reactions should be equal before adding. If you do that, it will cancel out automatically. Okay. So now 6 Fe plus 2 giving 6 Fe plus 3 plus 6 electron, and this is our equation number 2, and previous one, this is our equation number 1. Now what you have to do? Add 1 and 2. Adding 1 and 2. Adding 1 and 2. So what was 1? Cr2O7 2 minus Cr2O7 2 minus plus 14H plus 6 electron giving Cr2O7 2 minus 14H plus 6 electron giving 2Cr3 plus 7H2O. 2Cr3 plus 7H2O, and here you can add 6Fe plus 2, and here you can add 6Fe plus 3 plus 6 electron. Cancel the 6 electron and write the final answer. Final answer is Cr2O7 2 minus plus 14H plus 6Fe plus 2 giving 2Cr3 plus 7H2O plus 6Fe plus 3. This is the balanced reaction. Hope this is clear, students. It's so easy, and once you understand the steps properly, you can do it yourself within seconds actually. Okay. Now let's do one more problem. Let's do one more problem. See, next example is MnO4 minus. If this is clear, students, please let me know in the comment section. SO3 2 minus giving Mn plus 2 plus SO4 2 minus. Okay. Now first you have to identify the oxidation half reaction and reduction half reaction. So let's find out the oxidation state of MnO4 minus. So in the case of Mn, it is X plus 4 into minus 2 equal to charge on the molecule minus 1. So X minus 8 equal to minus 1, X equal to 7. So here manganese is having oxidation state of plus 7 and here it is having plus 2. That means this is our reduction reaction. Now let's consider the oxidation state of sulfur on the LHS and RHS. So LHS, it is X plus 3 into minus 2 equal to charge on the molecule minus 2. So X minus 6 equal to minus 2. So X equal to plus 4. So this is plus 4 and this is X plus 4 into minus 2 equal to minus 2. So X minus 8 equal to minus 2. So X equal to plus 6. So actually we need not have to do this since the charges are same, but the number of oxygen is different. As the number of oxygen increases, the oxidation state increases. That we know, that we have studied that, right? So this is the oxidation reaction. Now let's separate them and start balancing. So MnO4 minus giving Mn plus 2. So first let's check manganese. Manganese is balanced here. Now here there are 4 O, so I will add 4 water molecules in the LHS. Now I have to balance hydrogen. For balancing hydrogen, I have to add 8H plus here. Okay, 8H plus. Now hydrogen is balanced here, 8 hydrogen, here 8. So manganese is balanced, oxygen is balanced, hydrogen is balanced. Now charge. Here there is 1 minus charge. Here there is 8 plus charge. So in total 7 plus charge is there. Here there is 2 plus charge, right? Only 2 plus charge. So in order to balance them, I have to add 5 electron here so that the 7 plus charge will reduce to 2 plus charge. So balancing of the first reaction is complete. This is our first reaction. Now let's move on to the next one. That is the second one, SO3 minus 2 and SO4 minus 2. SO3 2 minus giving SO4 2 minus. Here sulfur is balanced, oxygen is not balanced. Here only 3 oxygen, here there is 4 oxygen, so I have to add water molecules over here. Now oxygen is balanced, 4 oxygen in the LHS and 4 oxygen in the RHS. Now we have to balance hydrogen, so 2H plus I have to add because in the LHS we have 2 hydrogen atoms. Now we have to check for the charge. Here it is minus 2 charge, here it is minus 2 and plus 2 charge, here minus 2 and plus 2 charge. So both the charges cancels out, so the charge here is 0. So here it is 0 and here it is minus 2. So I have to add 2 electron here so that both the side becomes charge equals, minus 2 and minus 2. So this is our equation 2. Now what you have to do? We have to add both the equation. So before we have to ensure that the number of electrons on both the equation is same. So here the number of electrons is 5 and second equation the number of electrons is 2. So in order to balance them, what I have to do is that I have to multiply 5 with this equation and I have to multiply 2 with this equation, so that both the number of electrons will get balanced. So 2 MnO4 minus plus 16H plus 10 electron. Whenever you have two different numbers, just swipe the numbers and multiply it with both the equations. That's what you have to do, giving 2Mn plus 2 plus 8H2O. That's the equation A. Okay. Now in the second equation you have to multiply with 5. So we get 5SO3 2 minus plus 5H2O, giving 5SO4 2 minus plus 10H plus 10 electron. That is equation B. Now let's add both the equation. Here we have 2MnO4 16H plus 2MnO4 16H plus 10 electron 2Mn2 plus 10 electron, giving 2Mn2 plus 8H2O plus 8H. This is our equation A, and we are adding both the equation. 10 electron cancels. Here we have 5H2O, here we have 10H2O. So 5 minus 8H2O is minus 3H2O. You can take that 3H2O over here. So it becomes plus 3H2O, or you can take 5H2O to LHS to RHS, so that it becomes minus 5H2O. Minus 5H2O plus 8H2O becomes 3H2O. So here you get 3H2O and 10H plus 5SO4 2 minus plus 2Mn plus Mn2 plus. In the LHS we have 5SO3 2 minus plus 2MnO4 minus plus 16H plus. So this is the final answer. Okay, so hope this is clear, students. There is 10H plus on the RHS and 16H plus on the LHS. You can take this to here, so that it becomes 16H plus minus 10H plus, that means 6H plus. So 5SO4 2 minus plus 2MnO4 minus plus 6H plus, giving 5SO4 2 minus plus 2Mn plus 2Mn2 plus 3H2. So this is the final equation. Okay, so now we are going to discuss about the alkaline medium. In alkaline medium, you can see that what is the trick? I am using a trick to solve it. So in alkaline medium, this is the redox reaction A giving B, and here you can see that we have used OH minus in order to indicate that the reaction is taking place in alkaline medium. So here the trick is balance assuming it as acidic medium and eliminate H plus by the help of addition of equal OH minus at both sides. So what you have to do, the trick is so simple that you assume that it is in acidic medium and you solve all the problems. That means you balance everything what you have did in the acidic medium. Likewise, similarly you do all the things, and final reaction, the final, after balancing, after cancelling the electrons, the final reaction you will have H plus. Now we are using the trick there. How many H plus is present in the particular reaction? That much OH minus you should have to add there and on the next side also. So say if in the final reaction there is 3H plus, say in the final reaction there is 3H plus, what I have to do? just add 3 OH minus in the LHS and 3 OH minus in the RHS. That's all. So 3H plus and 3 OH minus will give you 3H2. You just change it to that, and now the reaction is in basic medium. There is no H plus in the reaction. It's a simple step, right? So this is the trick we are going to use. Shiva, why sir, why no one's watching you? Mainly the students watch this after the recording. Okay, after the live they will watch. So 3H plus plus 3 OH minus giving 3H2, it gets converted to 3H2 and it gives 3 OH minus. So this is how you have to do. So in the case 2, in the basic or alkaline medium, what you are doing, we assume that it is in acidic medium and we do all the problem, and then what we will do is that in the final reaction we have to cancel out H plus. For that, what we will do, we will add OH minus in equivalent amount of H plus, so that the H plus converted to H2O, and in the right side or in the other side there will be OH minus. That means indicating now the medium is alkaline in nature. Okay. Now let's check the same method, steps on how to do this. So we have to separate the oxidation and reduction half reactions. First of all, we have to separate the, you will be given with the oxidation and reduction, or you will be given with the redox reaction. What you have to do is that you have to separate oxidation and reduction half reaction, and what next you have to do is that balance all elements other than hydrogen and oxygen first, that we have discussed it, and add water where oxygen atoms are more. Okay, and that is number of oxygen atoms, number of water equal to difference in oxygen atoms at both sides. Okay, and add OH minus in the opposite side where water is added. So number of OH minus is equal to 2 into number of H2O added. So add electron to balance charge, add both half reactions such that electrons are cancelled. Actually, this is the proper method of solving a reaction in alkaline medium. You can follow these steps and you can just do it that way, or you can use the trick which I have told you. The trick is the easiest way. Instead of getting confused with the acidic medium and basic medium, we will do all the problems as if it is in acidic medium, but at last only we convert them into basic medium. That will be the proper method to go for. I just have given the steps to do it directly with the alkaline medium. So I do not prefer this method, but in fact I prefer the trick which I have told you. So we'll be doing two problems where which I use the trick to solve the problem. Okay, so let's get started. The first one is question: Cl2 plus IO3 minus giving IO4 minus plus Cl minus. Okay, so here first of all you have to assign the oxidation states or oxidation number. The first one is 0. Here the oxidation number is -1. Now in the case of so we got the reduction reaction. So Cl2 is undergoing reduction here. Okay, now IO3 minus and IO4 minus, we have to find out the oxidation state of iodine, that is x plus 3 into -2 equal to -1. So x minus 6 equal to -1, x equal to +5. Similarly, in the case of IO4 minus, x plus 4 into -2 giving charge on the molecule, that is -1, x minus 8 equal to -1, x equal to +7. So here it is +5 and here it is +7. That means this compound is undergoing oxidation. So we got both the half reactions, that is a reduction reaction as well as oxidation reaction. Now let's separate them. Cl2 giving Cl minus. So here you have to balance what? Balance chlorine atoms. Here it is 2, here it is only 1, so I have to put 2 here. Now there is no hydrogen, there is no oxygen. Now balance only the charges. Here it is -2 charge, so I have to add 2 electron here, so that in the LHS and RHS the charges will be -2. That's it with the chlorine. And now moving to IO3. IO3 minus giving IO4 minus. So first of all, look into iodine. Iodine is already balanced. Now we have to look into oxygen. In order to balance oxygen, you have to use water molecule. So I will add one water molecule here, so that in the LHS 4 oxygen atoms, and RHS also we have 4 oxygen atoms. Okay, Savio, hi. Now oxygen atoms are balanced. Now you have to balance hydrogen atoms. We are assuming, actually this reaction is in basic medium, but we are assuming that it is in acidic medium, and we are solving it, and finally we convert into basic medium. That's the trick you have to use here. So I'll add 2H plus over here, 2H plus. Okay, now we have to balance the charges. Here only -1 charge, here -1 charge, here 2 plus charge and 1 minus charge. That means +1 charge. Okay, so I have to add 2 electron here, so that this +1 charge get cancelled and -1 charge will be given to this side. Okay, so +1 charge can be converted to -1 charge by adding 2 electron. So we have balanced both the sides. Now what you have to do? Here it's 2 electron, here it's 2 electron. So now the electrons are also equal in both the side. So now you can add both the reaction. So adding both the reaction, we get Cl2 plus IO3 minus plus H2O plus 2 electron, giving 2Cl minus plus IO4 minus plus 2H plus plus 2 electron. So cancel that 2 electron, 2 electron. Now what you have to do? We have 2H plus here, so add 2 OH minus in order to convert them into what? Basic medium. So how much OH minus you have added on the RHS, you have to do the same on the LHS. 2 OH minus here. So we will get the final answer as Cl2 plus IO3 minus plus H2O plus 2 OH minus, giving 2Cl minus plus IO3 minus, IO4 minus plus 2H2O. Okay, so you can see that okay, maybe I am covering the small portion there. Let me rewrite it here. Okay, let me rub this and rewrite so that it will be visible for you. So Cl2 plus IO3 minus plus H2O plus 2 electron on the LHS side, and adding the RHS, we get 2Cl minus plus IO4 minus plus 2H plus 2 electron. Cancel the 2 electron. Now H plus is present in the reaction. We are doing it in basic medium, so we have to cancel the H plus. For cancelling the H plus, you have to add 2 OH minus. How many H plus are present? You have to add that much OH minus, and where you have added OH minus, that much OH minus I have to add it on the opposite side. So here also I have to add 2 OH minus. Okay, is that clear, students? Is that clear? Yes. Now let me take the next page and see what is the final answer. Cl2 plus IO3 minus plus 2 OH minus. Here there is one H2O, and here 2Cl minus plus iO4 minus plus 2H2O. Here we can see that there is one H2O in the LHS and 2 H2O on the RHS. So take this H2O to RHS. So we will be getting Cl2 plus iO3 minus plus 2OH minus, giving 2Cl minus plus iO4 minus plus 2. So this is the final answer. Hope this is clear, students. Now let's do one more problem so that this concept will be thorough for you. I2 giving I minus plus iO3 minus, and it is given as basic medium. Okay, what is the trick we are going to use? We will be solving the problems as if this reaction is taking place in acidic medium. Then in the final step we convert into the basic medium. Okay, so first here it is I2, it is 0, I minus, it is minus 1. Here it will be x plus 3 into minus 2 equal to minus 1. So x minus 6 equal to minus 1. So x equal to plus 5. So this is plus 5. So the redox reaction, here it is reduction and here it is oxidation. Now separate the reduction and oxidation reactions. Sorry for that. I2 giving I minus, okay, and I2 giving iO3 minus. First balance iodine, so I have to put 2 here. Now you have to balance only charge. Here there is 2 minus charge, so add 2 electron here. That's all. Finish. Here I have to balance I, so I have to add 2 here. Here I have 6 water, so 6 oxygen, so I have to add 6 water here. Now I have to add 12 H plus here. Now balance the charges. Here it is 2 minus charge and 12 plus charge. That means total 2 minus and 12 plus means 10 plus charge. So in order to, here there is no plus charge. Here it is 0 plus charge. Here it is 10 plus charge. So I have to add 10 electron here so that the charge will get balanced. So before adding both the reaction, we can see that here it's only 2 electron, but here it's 10 electron. So if I multiply it with 5, I'll get 10 electron here. So I multiply it with 5. So we get 5I2 plus 10 electron giving 10 I minus. Now we'll add both the reactions. Now LHS side, 5I2 plus I2 plus 6H2O plus 10 electron, giving on the RHS side 10 I minus plus 2 iO3 minus plus 12 H plus 10 electron. Cancel the 10 electrons and now everything is okay except here it is H plus. So I have to add 12 OH minus, and whatever I have added, I have to add it on the LHS also. Now here we will be getting, the RHS will be getting 10 I minus plus 2 iO3 minus plus 12 H2O. 12 H2O, and on the LHS we get 6 I2 plus 6 H2O plus 12 OH minus. Now here you can see 12 H2O and 6 H2O. You can take the 6 H2O to RHS so that there it becomes 6 H2O. So the final answer will be 6 I2 plus 12 OH minus, giving 10 I minus plus 2 iO3 minus plus 12 H2O. It's not 12 H2O, it will be a 6 H2O. Okay, 6 H. So that's it. That's the reactions. Okay, so this is how we balance the reactions, right? So we have done both the acidic and basic mediums with using the oxidation half reactions, right? Now the next method is oxidation number method, and this is the last method with which we have to balance. So oxidation half method. So in oxidation half method is also a simple method where you can use this method to solve the problems in your competitive exam. It is less time consuming, not the other one. It is far more less time consuming. But what you have to do is that you do both the methods, and you prefer, maybe for some students the half reaction method is simple, some students oxidation number method is simple. So what suits you best, you can choose that. Okay. So here you can see, write the correct formula for each reactant product. That's the first step you have to follow. Write the correct formula for each reactant and product. Then what you have to do is that identify atoms which undergo change in oxidation number in reaction by assigning the oxidation number to all the elements in reaction. So what you have to find out is, you have to find out the atoms which undergo change in oxidation number. So first you write the correct formula, then you assign the oxidation number and identify the atoms which undergo the change. Okay. Now find change in oxidation number and equalize it. So you have to understand the difference in oxidation number. What is the difference in oxidation number? And you have to equalize that difference. Now balance ionic charge by adding H plus or OH minus. H plus if in acidic medium, or OH minus in basic medium. And finally add water to balance oxygen and hydrogen. So these are the steps which you have to follow in order to solve the problem. So let's do one or two problems so that these steps will be clear for you. Okay. So here you can take the example question: MnO4 minus plus Fe2 plus giving Mn2 plus Fe3 plus, and it is given that it is acidic in nature. Okay. So what you have to do? What you have to do is that you can just check it here. Wait a minute. Yeah. You can just check it here that in the case of manganese, here it's +7. Okay. So here it is decreased by, oxidation number is decreased by, oxidation number decreased by 5. From +7 it has decreased to +2. So it is decreased by 5. Here you can see that in the case of iron, the oxidation number has been increased by 1. The oxidation number is increased by 1. Okay. What you have to do is that you have to equalize the change, equalize the difference. So here it is 5, here it is 1. So what you have to do, I have to make it 5. So in order to do that, I have to multiply it with 5. So now what happens is that here this, now we can separate it, MnO4 minus giving Mn2 plus. That is the reduction, and Fe2 plus giving Fe3 plus. That is the oxidation. From here there is a change in 5, so we have to multiply it with 5. So that is done. 5 Fe2 plus and 5 Fe3 plus. Okay. Now that has been done. Now what is the next step? Next step is you have to balance it, right? So you can now in both the sides. Now what about the charges? Charges also we have to balance it first, then finally we'll first we have to add. In the previous equations or previous step, what we have done is that we have balanced the half reactions completely, then we add it. Here what you have to do is that now first we will add both and then we will balance it. Okay, that's what we have to do here, right? So we can add both the reactions. So MnO4 minus giving Mn2 plus. Here the oxidation number is decreased by 5. and then the second is Fe2 plus. So we have Fe2 plus giving 5 Fe3 plus. Here it was previously oxidation number increased by 1. So that's why we multiply it with 5. And now what you have to do is that you have to add both. So MnO4 minus plus 5 Fe2 plus giving Mn2 plus 5 Fe3 plus. Okay. Now see here, there is 4 oxygen. So in order to balance 4 oxygen, I have to add 4 water here. 4 H2O. Okay, now oxygen is balanced. Now here there is 8 hydrogen. So in order to balance hydrogen, I have to add 8 H plus here in the LHS. Now elements are balanced. Now check for the charge. Here there is 1 minus charge and 10 plus charge and 8 plus charge. So 10 plus 8, 18 plus minus 1, 17. Here there is 15 plus 2, 17. So both the sides the charges are equal, right? Here there is 17 plus charge, here also 17 plus charge. So no need to balance the charges. This is the final answer. I hope this is clear, students. Now let's do one more problem and wind this session. Question. MnO4 minus plus Br minus giving MnO2 plus BrO3. Sorry for that. Plus BrO3 minus, and this we are doing in basic medium. Remember, in basic medium you cannot use H plus in order to balance. Instead we have to use OH minus to balance the hydrogen. Okay. So let's check here. Here it is minus 1. Bromine it is minus 1. Here it is X plus 3 into minus 2 equal to minus 1, that is X minus 6 equal to minus 1. So it is X is equal to plus 5. So here it is oxidation. So it is increased by oxidation number increased by 6. From minus 1 to plus 5, it is increased by 6. Now let's consider Mn. It is X minus 8 equal to minus 1. So X equal to plus 7. So here it is plus 7. Here it is plus 4. That means it is decreased by 3. So it is decreased by 3. So in order to make the value same, oxidation number decreased by 3. In order to make the value same, I have to multiply this with 2 so that it will get decreased by 6. So there increased by 6, here decreased by 6 when we multiply it with 2. So let's separate that. MnO4 minus giving MnO2. Here we know that oxidation number decreased by 3. The second one, Br minus giving BrO3 minus. Here we know that the oxidation number is increased by 6. So what you have to do is you have to multiply it with 2 so that the increase and decrease will get balanced. So 2 here and 2 here. Now what you have to do, just add the reactions. 2MnO4 minus plus Br minus giving 2MnO2 plus BrO3 minus. Now here there is 8 oxygen, here there is 7 oxygen. Okay, so 8 oxygen and 7 oxygen. For balancing in basic reaction, what you have to do is that you have to add the water on the side where oxygen is more. So what is the difference actually? Here there is 8 oxygen, here there is 7 oxygen. So 1 oxygen is the difference. So where it is more, I will add 1 water molecule. That is the change. Okay, that is the change when you do it in the basic medium. So now it is not balanced. Now it's not balanced, we know that. Now let's check here, there is 2 hydrogen. So we will add 2 OH minus here. Now let's check the oxygen, it will be balanced. And also hydrogen, at the same time hydrogen also will get balanced. So 8 oxygen here plus 1, 9 oxygen. Here 4 plus 3, 7, 7 plus 2, 9 oxygen. It is balanced. Now hydrogen, H2, here also 2H. Okay, so hydrogen is also balanced. Now what's left? Charge. Here 2 minus charge, 1 minus, so total 3 minus charge. Here also 3 minus charge in total. So it is already balanced. So this is the answer. So I hope students this is clear. So when it is in basic medium, only one thing you have to remember. If you are doing it in basic medium for the oxidation half reactions, what you have to do is that you have to add the water molecules corresponding to the number of oxygen atoms, difference in number of oxygen atoms at the side where oxygen atom is more. Okay, you add water there, then on the opposite side you balance hydrogen by using OH minus, then automatically oxygen and hydrogen will come to balance. Okay, that's what you have to remember. So we have discussed these two methods in detail by solving numerous problems. If you are watching this channel directly, means this session directly, I tell you, you have to first watch the previous lesson. If you do not know how to identify or how to understand the oxidation state or how to elicit the oxidation number of the elements, that is taught in the first lesson. So you have to watch that first lesson, then only come to this lesson, so that you will not find it difficult. Okay, so balancing is very important if you are considering with NEET exam or for JEE exam. Balancing of the redox reactions is one of the most important in both the exams, as per from the questions asked from redox reactions. In the previous year examinations, in the previous year questions, you can see numerous questions have been asked from these sections. Okay, so be aware of this, prepare this properly, and what you have to do, you have to revise it, you have to do more problem. Okay, so I hope this is clear for you, and with that, let's wind up. Let's just give a brief idea on what we have discussed today. So we started on with the half reaction method, where it is also called as ion electron method, where we divide them into ions and we add electrons, and just remember that name also. Okay, half reaction method or ion electron method. In that we have discussed about the acidic medium, and also we did certain problems on that, and then we told about the basic medium, where I have taught you a trick in which you do it by assuming that the reaction is taking place in acidic medium, and in the last step we convert them into basic medium by adding OH minus on both the sides. Okay, then we studied about the oxidation number method, and oxidation number method both the ways. In acidic medium also we studied, and in acidic medium, what is the difference between acidic and basic medium? In acidic medium we add we balance oxygen by taking water molecule on the opposite side, but in the basic medium we add water on the side where oxygen number of oxygen atoms is more, and then we use OH minus to balance hydrogen, and in the acidic medium we use H plus to balance the hydrogen. That's the only difference you find in acidic as well as in basic medium. So hope this is clear, students, and I thank you for watching the lessons, and I wish you all the best if you are writing tomorrow's exam, that if you are appearing for NEET exam tomorrow, I wish you all the best from my part and as part of APJ Academy, and do your duty well, do your problems well, don't be afraid, don't feel any tension, be relaxed, go to the examination hall, whatever comes in front you give your best, and left you leave it with the God. Okay, that's how you have to go and attend any competitive exam. So be cool, be calm and composed, go and give your best shot tomorrow, and I wish you all the best. Thank you, students. Thank you. Have a nice day.